Hello, math students. I am going to talk about lessons 19 through 21 in this video. I want to just go over a few examples and show you how I did them. And if you have any questions, please let me know. So these lessons, actually we're doing lessons 19 through 22, sorry. These lessons do have a lot of stuff that we would have covered in geometry or algebra 1, so that's nice. It should look kind of familiar to you. So I'm going to show you my paper here and try to explain. So lesson 19, example 1. So in this example, and you can go ahead and turn into your book to this page, this will be page 94. It says, Karamagu had 50 nickels and dimes whose value was $4. How many of each coin did he have? So what I do is I set it up as I have in sub n, so that just means number of nickels plus the number of dimes is going to equal 50 because they told us he has 50 total. Next, I know that whatever the value of the n's plus the d's, it's going to equal $4. So we know that nickels are worth 5 cents. So I put 0.05. $1 would be like this, right? So 5 cents looks like this. Dimes are represented by 0.1. I put the 0 there just because it looks like 10 cents. So you can see that. You can almost imagine a little dollar sign there. Okay. So what I do is these are the two really important equations to start out with. So with what they told me, I can say, okay, well, 0.05 times that number of nickels plus 0.01 times that number of dimes. Sorry, that's supposed to be 10, not 01, equals 4.0 or just 4. Okay, I hope this makes sense. If it doesn't, let me know. But just think if I have like 5 nickels, then they're each going to be worth 5 cents. So that's kind of how that's set up. Now, next, with this information, I need to get an equation that only has one variable to solve. So either n sub n or n sub d. So I'm just going to say, let's do, let n sub n equal 50 minus n sub d. Now, where did I get that? Oh, I just rearranged this first one. Okay, so n sub n equals 50 minus n sub d. And I can plug that into the bottom equation to solve. So I took this equation here and I just plugged in the 50 minus n sub d in for n sub n. So now I have a whole new equation here. And I have something that I can solve for because I only have one variable now, that's n sub d, meaning again, the number of dimes. So I take that 0.05, distribute it out, and that gives me 2.5 minus 0.5 n sub d, and I solve, and I get n sub d equals 30. It's a very nice number considering that we started out with decimals. And then with that, I could now plug that 30 in for my original equation and easily see that n sub n equals 20. Now, it would have been easier, and your book will show this example on page 94. They actually changed the equation to be whole numbers, so they multiplied everything by something. What did they do? Well, you can read about it in your book. Anyway, they multiplied like the whole equation by a whole number just to get rid of the decimals. The decimals didn't bother me, but that is something you can do. It doesn't change the value of the equation as long as you do the same thing to both sides. Okay, this kind of question is definitely almost 100% going to be on the ACT. So make sure if this is uncomfortable for you that you practice some of these and get that under your belt. Okay, example 3. Now this is different, but also something we did in geometry. So just so you know, SF equals scale factor, if you're wondering, in example 3. But they want you to find X and Y. All right, so what I know is that I've got these. Now, I wrote my angles a little differently than they did. I did a double arc where they did 2 tick marks, and I just didn't really like that as much. This is how I learned it, so y'all can do it either way. But I know that these angles are the same and that these are also congruent. So that means 4 and 6, there's something special about their relationship. 4 times something equals 6. There's that scale factor in there that gives me 6. So I need to find out what that scale factor is. So I just simply set it up like this. 4 times scale factor equals 6. And I find out that the scale factor is 3/2. So that's saying that this is kind of the proportion that we have going on here. So we can use this to find y. So 7 times that scale factor is going to equal y. So I can multiply that out and find that 21/2 equals y. And I can do the same thing with 5 and x. So 5 times 3/2 equals x. Again, you're using that same scale factor throughout. And I can find those numbers. So that is not a super bad problem. Okay, next, lesson 20. We talk about radicals and parallel lines. So simplification of radicals. This one I think we first see in pre-algebra, and it just keeps on coming back. And it's something that is easy to forget, but then easy to bring back to mind. So I will let you guys read that example, but if you have any trouble, really example 1, 2, and 3, please let me know, and I'll be glad to write this out with you. What I want to say about parallel lines is really these are a lot of fun. Parallel lines, when you graph them, all you need to know is that they'll have the same slope as a line. The parallel lines have the same slope. If you've got perpendicular lines, then, well, this book hasn't talked about it yet, but then it will be opposite and negative of that slope. So here, I love these. Example 4. Find the equation of the line that is parallel to this guy, except it passes through the point 3, -1. Okay, so the first thing we need to do before we do anything else is write this equation in slope-intercept form. Okay, so I hope that you can figure out how to do that. We solve for y, so they just added x over here and then divided the whole thing by 2. So this is our slope-intercept form. So the slope of the new line must also be 1/2 if it's parallel to this line, okay? So 1/2 is our slope that we're going to use. Now, what's interesting about these is we take that slope and we say, okay, my new equation is going to be y equals 1/2 x plus b, and I don't know what b is, so I need to figure that out. How do I find b? Well, they gave us this point 3, -1 that we know the line passes through, so I'm actually going to take that x value and that y value and plug it into this equation. So that's where we get that -1 equals 1/2 times 3 plus b. Works out beautifully to get this nice little fraction, -5/2 equals b. And that is my y-intercept. So now I can write my equation, y equals 1/2 x minus 5/2, and it just really wasn't that bad. So that is how you write the equation of a line parallel to another line. That's a lot of fun. That is a fun Friday night right there. All right, let's go to lesson 21. We're just flying through these. I also know that YouTube doesn't like long videos from me, so I'm trying to make it shorter. Lesson 21, scientific notation. Y'all have been doing this forever. Now, we definitely have done this before, but just a refresher in example 1. We'll look at my notes. this time. Okay, so they want you to simplify all this. It looks pretty rough, but it's not really that bad. The first thing you need to do is write everything in scientific notation. It may look like it's in scientific notation, but it's not finished. So just a reminder of how to write a number in scientific notation. You put your pencil right after that whole number, the first whole number you see, and then count to the left or to the right, in this case, the left. So if I do this, put my pencil there, and I go 1, 2, 3, 4. It took me 4 steps to the left to get to my decimal. Therefore, my new number, it correctly in scientific notation, is actually going to be 3.0 times 10. I took 4 more steps to the left, which was negative. So instead of a -6 power there, I've got a -10. Okay. Now here with my 4,000, I put my pencil right here and I go 1, 2, 3 steps to the right. So that actually becomes 4 times 10 to the 3rd power. Now you can write the 0.0 or you don't have to. Next, in the denominator, same thing. I put my pencil there and I go 1, 2, 3. So that was -3. So I've got to change that times 10 to the 15th power to the 12th power because we had -3 going on there. And I've got the 2,000 becomes 2.0 times 10 to the 7th power. The next step is to multiply or divide. And this is what I mean. So I can actually take this number here and this number here, seeing that they are both of the same look, I suppose you could say. They're both the whole numbers there. And I can group them together to do 3 times 4. Then I can take this guy and group them together to do 10 to the -10th power times 10 to the 3rd power, 10 cubed. When I work that out, I get 10 to the -7th power because remember, you add exponents in this case. Okay, same thing in the bottom. I do 6 times 2. I grouped this guy, and then I grouped this one and this one, added those together to get 10 to the 19th power. Then I just start reducing a little bit. I've got a 12 over 12. That's nice. We can say that's 1. And then over here, I've got a 1 over 10 to the 26th. Please remember that our negative exponent comes down and becomes, what I did here was 10 to the 19th power times 10 to the 7th power, and you add those together, and that becomes 10 to the 26th power. But it is in the denominator, so if you want it to be in the numerator, you need to convert that back to being a negative, okay? All right, example 2. So this is a totally different concept. 2 statements of equality. Example 2 says the ratio of 2 numbers is 3 to 4 and their sum is 84. What are the numbers? These aren't so bad. So what they decide to use is fine with me. They use n for numerator and d for denominator. That makes sense. So a ratio, remember that can be set up as a fraction. So we've got 3 over 4. And so n over d equals 3 over 4, and n plus d, they tell us, equals 84. So now I've got these 2 statements of equality here. What do I do with them? Okay, well, first of all, in our equation A, they cross multiply, so 4n equals 3d, okay? Not a big deal there. But look what I can do here. This is always fun. So I can solve for d so that I have only one variable to deal with, because I can't actually solve for both of them if they're both in the equation. I need to solve for one at a time. So I let d equal 84 minus n. I could have let n equal 84 minus d. That would have been fine, but they just chose d. That's good. So now I plug that in here for d. And then I have 4n equals, I distribute that 3 out and I get n equals 36. Then I can plug that 36 back into this equation to get 84. And then the answer is 48 for D. All right. Lastly, let's talk about lesson 22. I believe this is a common one on the ACT, if I remember correctly, from looking at that review. So, distance. I believe y'all have done these before as well. But let's talk about this one. Roger made the trip on Sunday. Judy made the same trip on Monday. Roger traveled at 12 miles an hour. Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's time. How far did they travel? Okay, so let's not panic. Let's just write down what we know. So I know, first of all, let's get this in our minds. D equals RT. This is like essential on these problems. This is saying distance equals rate times time. And we're just going to get comfortable with subscripts. They're not bad. So distance equals rate times time. So in this case, the rate of Roger times the time of Roger equals the rate of Judy times the time of Judy. Okay, the distance, this is because the distance was the same. They told us that. They made the same trip. So if their distances are the same, then their RTs are the same as well. Okay? So next, I also know that my time, Judy's time, is equal to the time of Roger minus 2. Because they told us that her time was 2 hours less than Roger's time. Or you could put it like this, TR equals TJ plus 2. So I take those, then I come down and I just start having fun plugging things in. So the rate of Roger, they told us, was 12 miles an hour. We don't know that his time. Equals 20, which is Judy's rate, times what I plug in for TJ. T sub j. So T sub r minus 2. I could have also, as I showed, I could have also done T sub j plus 2 and plug that in for this guy. So from there, I solve it out, distribute, find T sub r equals 5, and then I can plug that 5 back in to my original equation to find T sub j equals 3. So these are not bad either. Here, if you want to pause your screen, you're welcome to. This is example 2 written out, but I'm not going to go through that example. If you have any questions, to reach out. I want to help. I would love to help you and make sure that you understand everything. So stay on the math train, and I will see you Thursday.